Good morning, everyone. Let's start Maths, Grade 6, Chapter 6, Perimeter and Area. Learning objectives. After this session, learners will be able to apply strategies to solve area maze puzzles, analyze and solve problems involving the concepts of perimeter and area. Area maze puzzles. In each figure, find the missing value of either the length of a side or the area of a region. Here, first one, it's given that this is 13 square centimeters, second one is 26 square centimeter, thus third one is 15 square centimeters. Now we need to find what is the area of this rectangle. If we observe here, this area we can write it as 13 into 1 L into B. This 26 can be written as 13 into 2. Similarly, 15 can be written as 15 into 1. If we observe here, this 13, this is having the same length. So if this breadth will become this 13, then length will be 1. If this breadth is same as 13, then this is 2 units. Therefore, we can consider the length of this also 2 units. Similarly, breadth of this one is 15. Therefore, the length is 2 centimeters and breadth is 15 centimeters. Thus, area is equals to length into breadth. Therefore, area is equals to 2 centimeters into 15. Nothing but 2 into 15 square centimeters. Therefore, area is equal to 30 square centimeters. Second puzzle B. Here, this is given puzzle. We need to find area of this one figure. If we observe here, this is 10. Already we know that breadth is 2 centimeters. Then the length total it will become here 5 centimeters because area is 10. 2 5 are 10. So 10 is coming. Here already 3 centimeters. So this will be 2 centimeters. If this is 2 centimeters, then length will become 5 centimeters because area is 10 square meters. Here in this 5 centimeters, this is 2 centimeters. So this will be 3 centimeters. Then now length is 3 centimeters and breadth also 3 centimeters. Therefore, we can write area is equal to length into breadth. Area is equals to 3 into 3 square centimeters. Therefore, area is equal to 9 square centimeters. Let us see C. If we observe here, this area is given as 42 square centimeters and we know breadth as 6. We can write it as 42 divided by 6 is 7. That means 7 centimeters is the length. Now, in this rectangle, 7 plus 5, 12. So, length will become 12. Here we know that area of this rectangle is 60 square centimeters. Thus, here, this breadth will become 5 centimeters because 60 divided by 12 is equals to 5. Now, among this one, 5 we know this is 6. Total is 11. Therefore, 15 minus 11 is, this will become 4 centimeters. And length here is this 3 centimeters and this is 5 centimeters plus 7 centimeters is 12 centimeters. Here, so this is 7, 7 minus 3, 4 centimeters. Therefore, length is 4 centimeters and breadth is 4 centimeters. Area is equals to length into breadth. 4 centimeters into 4 centimeters. 4 square centimeters. Therefore, area is equals to 16 square centimeters. Let us see question number D. Here, this rectangle given as is 18 square centimeters as area and length is 5 centimeters. Therefore, here breadth is equals to area divided by length. Nothing but 18 divided by 5 is equals to 3.6 centimeters. Therefore, this is 3.6 centimeters. Therefore, total breadth of this will be 3.6 plus 4. Nothing but height will be 7.6 centimeters. and area is 38. Therefore, length will be area divided by breadth. 38 divided by 7.6, nothing but 5 centimeters. Therefore, length of this rectangle is 5 centimeters. Let us see, figure it out. Question number 1. Find the dimensions of a rectangle whose area is sum of the areas of these two rectangles having the measurement 5 meter by 10 meter and 2 meter by 7 meter. So these are the two rectangles. So considering the measurements as a 5 meter by 10 meter and 2 meter by 7 meter as per given problem, area of the rectangle is equals to, rectangle 1 is 5 into 10, that 50 meter square, and area of rectangle 2 is 2 into 7, 14 meter square. Total area is 50 plus 14 means 64 meter square. Therefore, the possible area chances of this length and width will be 64. We can write in the factors as this: 1 into 64, 2 into 32, 4 into 16, 8 into 8, 16 by 4, 32 into 2, 64 by 1. So, one rectangle with this area 64 square meters has a dimension. We are opting this as 8 as a length and 8 as a width. You can opt with whichever is following. But most probably this is having the dimension 8 meter by 8 meter. All possible dimensions of the rectangle with an area 64 square meter are shown in this table, which gives us the area as 64. Figure it out. Question number 2. The area of a rectangular garden is 50 meter long, is 1000 square meter. So, a garden is there, the length of the garden is 50 meter and the area is 1000 square meter. Find the width of the garden. Here we know area, so we can find width of the garden because L into B is equals to area. So, length of the rectangle garden is equals to 50 meter. This is given, and area of the rectangular garden is 1000 square meter. Therefore, width of the garden is equals to area divided by length. What is the area here? 1000 square meters divided by 50 meters, nothing but 20 meters is this width of the rectangular garden. Third question. The floor of a room is 5 meter long and 4 meter wide. A square carpet whose sides are 3 meter in length is laid on the floor. Find area that is not carpeted. So we have a floor of the dimensions of 5 meter by 4 meter and the carpet is of square shape 3 meter by 3 meter. So we need to find the area that is not carpeted. We need to subtract area of the floor minus area of the carpet. So let us see. The floor of a room was 5 meter long and 4 meter wide. So this is this floor. This is carpet. Therefore, area of floor is equals to 5 into 4, 20 square meter. Carpet area is 3 meters into 3, nothing but 9 square meter. So, area of the floor that is not carpeted is equals to total floor area minus carpet area. 20 square meter minus 9 square meter, nothing but 11 square meter is the area of the floor that is not carpeted. Question number 4. 4 flower beds having sides 2 meter long and 1 meter wide are dug at the 4 corners of a garden that is 15 meter long and 12 meter wide. How much area is now available for laying down a lawn? So we need to find out area of the garden and then we need to subtract 4 flower beds area. Then remaining area will be possible for this laying down a lawn. Let us see. Here this is this picture. So we have this rectangular garden kind of this one, which is having the length as is 15 meter and width as is 12 meter. This 4 corners we have this flower beds of this 2 by 1 means 2 meters length and 1 meter width as this one. The 4 corners. Now we need to find how much area is available laying down the lawn. So this entire is this lawn. So we need to subtract these 4 flower bed areas from the rectangle. Therefore, area of the flower bed having the sides 2 meter long and 1 meter wide is 2 square meters. So 4 such one area is 4 into 2, nothing but 8 square meter. Area of the garden is 15 by 12, nothing but 180 square meters. Therefore, area available for laying down a lawn is equals to 180 minus 8, nothing but 172 square meter. Figure it out. Question number 5. Shape A has an area 18 square units and shape B has an area of 20 square units. Shape A has a longer perimeter than shape B. Draw two such shapes satisfying the given conditions. Let us see here. Area of shape A is 18 square units and B has an area of 20 square units as per given problem. Thus, possible dimensions of A are 18 into 1, 9 into 2 and 6 into 3. Possible dimensions of B are 20 into 1, 10 into 2, 5 into 4. Therefore, area of A can be written as 2 by 9. Area of B is 5 by 4. Thus, an example that satisfies the condition that the perimeter of A is greater than the perimeter of B. Therefore, here perimeter of this A is 2 into L plus B. So, 2 into length is 9 units, 9. Width is 2. So, 9 plus 2, 11. 11 into 2, 22 units. So, area of the perimeter of this shape, A shape is 22 units. Then perimeter of shape B is equals to 2 into L plus B. L is 5 units, B is 4 units. 2 into 5 plus 4, so nothing but 2 into 9, nothing but 18 units. When we are comparing that, perimeter of A unit is greater than this perimeter of B. But the area of this A is less than this area of B. Similarly, let us see another example. Another example that satisfies the condition that perimeter of A is greater than B is, if we consider length as a 18 units and breadth as a 1 unit, then perimeter is 2 into L plus B. 18 plus 1 is 19, 19 into 2 is 38 units. And B perimeter, we can consider the length as 10 units and width as 2 units. We can write it as 2 into L plus B. 2 into 10 plus 2 is 2 into 12, nothing but 24 units. If we observe here, then perimeter of A is greater than the perimeter of B. But the area wise, area of A is less than area of B. Because if we observe here, the area of this A is 18 into 1, 18 unit square. Similarly, 10 into 2, 20 unit square, which satisfies the condition here, 20 square units, here 18 square units. Question number 6. On a page in your book, draw a rectangular border that is 1 centimeter from the top and the bottom and 1.5 from this left and right. So, what is the perimeter of the border? So, we have to take a rectangle book and we need to draw a border of this one. So, let us consider our notebook is having L centimeters and B centimeters and we are drawing this borders as specified. Let the length of this notebook is L centimeters and breadth is B. The border specification is 1 centimeter from top and bottom. So, this is a border. And left and right there is a 1.5 centimeters. Therefore, the perimeter of the border we need to find it out. Borders of 1 centimeter from the top and bottom are 1.5 and from the left and right are as shown in this figure. Then length of the notebook is, if this is total is L, with removing this border it will become L minus 1.5 minus 1 minus 1.5, nothing but L minus 3 centimeters. Similarly, breadth of the notebook is B minus 1 and minus 1, nothing but B minus 2 centimeters. Therefore, the perimeter of the border is equals to 2 into L plus b. The new length is L minus 3 centimeters, L minus 3, and this new breadth is b minus 2 centimeters. Therefore, minus 3 and minus 2 will be minus 5. So, 2 into L plus b minus 5. This units is centimeters. Therefore, the perimeter of the border is equals to 2 into L plus b minus 5 centimeters. Question number 7. Draw a rectangle of size 12 units by 8 units. Draw another rectangle inside it without touching the outer rectangle that occupies exactly half the area. Solution. Here we are drawing this rectangle of size, length as 12 units and breadth as 8 units. Then we have to draw another rectangle without touching this outer rectangle, but this area should be half of that one. So area of this one is 12 into 8 means here 96 units. As specified, the area of the rectangle with the size 12 units by 8 units is 96 square units. The area of the inner rectangle with size we are drawing is 8 units by 6 units, because the area will become 48 square units. If we compare that one, the area of the inner rectangle is equal to half of the area of our outer rectangle, because 48 can be written as half of 96. 2 1s are 2 4s are 2 8s are. Thus, the area of the inner rectangle is equals to half of the area of outer rectangle, which satisfies this condition. Let us see question number 8. A square piece of paper is folded in half. The square is then cut into two rectangles along the fold. Regardless of the size, the square, one of the following statement is always true. Which is true here? The area of each rectangle is larger than the area of the square. The perimeter of the square is greater than the perimeter of both the rectangle added together. The perimeters of both the rectangle added together is always 1.5 times the perimeter of the square. The area of the square is always 3 times as large as this area of both the rectangles added together. Let us solve here. First, let us take a square piece and let us fold it to this half. Then we will cut it as 2 rectangle units. Let us consider the length of the square piece unit as A in units. When we are cutting this one, the length of the rectangle will become A and the width will become A by 2. Now, perimeter of the square is 4A units. Perimeter of the rectangle is 2 into A plus A by 2, because length is A here, breadth is A by 2. Nothing but 3A units. And perimeter of both the rectangles is 6A units. 6A units we can write it as this 3 by 2 into 4A units. Thus, perimeter of both the rectangles is 1.5 times is the perimeter of the square. This statement satisfies the condition of this C. See, first one, the area of the rectangle is larger than the area of the square. This is not possible because we know that area will be always equal. The perimeter of the square, then we are considering that one, perimeter of both rectangles greater than, it might be greater, but we don't know how much, so that's the reason. Then the area of the square is always 3 times of this. This is also false. Then the third one is true, as perimeter of both the rectangles is 1.5 times the perimeter of the square, which we proved now. Thus, statement C is always true. Let's have a quick summary. The perimeter of the polygon is sum of the lengths of all its sides. The perimeter of rectangle is twice the length of its length and width. The perimeter of a square is 4 times the length of any one of its sides. The area of a closed figure is measure of the region enclosed by the figure. Area is generally measured in square units. The area of a rectangle is its length times its width, means L into B. Area of a square is length of any one of its sides multiplied by itself, side into side, or L into L. Two closed figures can have the same area with the different perimeters, or the same perimeter with different areas. Areas of regions can be estimated or evenly determined by breaking up such regions into unit squares or into more general shaped rectangles and triangles whose area can be calculated. Thank you.